So we've got this idea of uncertainty and error and measurement. We've got these two types of errors. We've got random and systematic errors. Now, systematic errors, let me start with that one over there, are errors due to the equipment that you are using. It's usually a regular error. It's usually an error of the same size. It's usually due to some sort of equipment failure. So, for instance, if I'm measuring using this scale, and this scale is out by a gram, then every single measurement will be out by the same amount. It will usually give you a graph. If you have a graph and this graph is supposed to go through the origin like that, what will happen when you have a systematic error, that you'll get either that or that. It knocks off all the values by a certain set amount and therefore knocks off your graph. So instead of being there, your value is there. It's knocking off by the same amount each time. And it shifts the graph either one way or the other way like that. That is an idea of a systematic error. It's defined here when we're talking about systematic error. It says an error associated with a particular instrument or experimental technique that causes the measured value to be off by the same amount each time. So that's a systematic error. Okay. Now, the idea with random error, this is more due to, as the word says, random. These are errors that occur in taking the measurements that can be in any direction. So it can either be in this, it can be different amounts. It can be, for instance, when you're measuring using a stopwatch, you may click too quickly or click too slowly. It's all over the place. And the way that we cope with random error is that we take a number of readings and then we find the average of them. That brings down our random error. So these are our two different types of error that we will be looking at. Now, we distinguish between this idea of precision and accuracy. Now, in doing that, usually we use the idea of just to help clear that out, of a target. So if you've got a target and you've got, this is the bullseye, this is where you want to try and hit. Now, precision is to do with the actual readings, how close the readings are. So if your readings are precise, they are all close together, like this. Those would be precise, but not accurate, because this is where we want to be. This is accurate. So because they're very close together, they will be precise, but not accurate. I don't know what's happening to my board here. It's a little bit slow. Anyway. Alright, so that's precise, not accurate. If I was around like this, this may be accurate, but not precise. You see, because they're all around where they should be, but they're a little bit spread out. If we took the average of these over here, then you would actually probably get a value that's pretty close to the actual value. So this would be accurate, this one over here, accurate, but not precise. And then obviously if you had the combination of the two, if you had a whole lot of readings that are all focused here, this would be the idea of precise and accurate. That's what we like. So in dealing with error, what we do is we look at the range of different values that we get. Okay, so that gives us an idea of how precise our values are. And then we also look at the average and we see how close it is to the actual value or the expected value. That gives us an idea of accuracy. And we'll look at both of those. Okay, this idea of random error over here, how it can be reduced, is that we take many readings and we find the average of them. And we also look at our experimental technique and we try and minimize those by improving our experimental technique. And we will look at that in more detail later.